Hello, class. I just wanted to make a quick recording just to explain how to do the assignment because I noticed that a lot of students have been having issues with it. Basically, I'm going to use an example just to illustrate how to do the assignment, but these values are not at all what are on the actual assignment. So you'll have to work through these steps on your own at home. But I'm going to use the example of women's cholesterol and whether or not a vegan diet lowers cholesterol levels in the average adult woman. So here, these are your given values. Population mean is 13.6. We've got our standard deviation of 0.86. Our population number is 100 that we are testing for our sample size. This is our sample mean, 12.5, and our p-value is going to be 0.05. For the first part, you're going to want to describe your population, and you're going to want to discuss whether or not the variables involved affect each other. For example, in this scenario, I'll be working with someone who's vegan or vegetarian and cholesterol levels. And then our population is adult women for this example. So we're going to determine for our null whether or not cholesterol levels of adult women who follow a vegan or vegetarian diet are no different than cholesterol levels of adult women from the general population. For the in the mathematical format, you're going to want to put the population mean. And the reason for this is because if there is no difference between women who have a vegan vegetarian diet and those who do not, and their cholesterol levels, then the population mean should equal the cholesterol levels for those who are having a vegan vegetarian diet. So the population mean 13.6 being the cholesterol level of just the general population in this scenario. If the null is, if we're going to accept the null, which is that all vegan vegetarian diets have the same cholesterol level as the population, then they will also have the same exact cholesterol level of 13.6, right? So we're going to put the alternative, which is that cholesterol levels actually decrease in women who have a vegan or vegetarian diet. So we're going to put that in mathematical format as that the population, basically, it's going to be less than the population average, 13.6, because we're assuming that there will be a decrease in cholesterol levels for this particular scenario. Now, if we thought that it would increase the cholesterol levels, we would put a greater than sign there, but we are believing it's going to decrease, so we're going to put a less than symbol for the mathematical format in this scenario. Based on the information in this scenario, what is the level of significance to be used? We already discussed above here. It's going to be the p-value is a 0.05, so that's for this particular scenario, but you could use different p-values, right? So for the next step, we're going to basically describe what kind of test we're going to use, and for this example, we're using a z-test. So if we're setting up our decision rule, this is basically, you're going to mathematically represent what level you're going to accept whether or not the vegan diet has decreased cholesterol in these women. So we're going to go by the normal distribution to figure out our z-score. So let me show you that. Here's the normal distribution curve. Here, this is the area that we're going to reject for our null hypothesis and for someone who has a decreased level of cholesterol. Now, if we thought they had an increased level, we'd be taking this group of people, correct? So we're going to try to figure out, this is our average population. We're going to try to figure out if the people eating the vegan or vegetarian diet fit into this category or this category over here. So in this case, we want to make sure that it's decreased, so we're only going to take the negative values on this side of the normal distribution. And that translates to we have to look at that in our z-score chart. So let's go over. Here's our critical values. You have a similar chart in your book, but these are all numbers that have been computed previously. You do not have to be experts at figuring out what z-scores are. That's to simplify that, you refer to a chart with critical values in it. So we look at our 0.05 significance level, and we have a negative 1.645 for that. So because we're on the left side of the tail, right? We're checking to see if the cholesterol levels decreased, which is our negative values on that normal distribution curve, right? If we wanted to see if it was positive, we looked at the positive values, and then we would be choosing the positive 1.645. But since this is a one-tailed example, not a two-tailed, we're going to go with the negative 1.645. And that will be used as our decision rule for our z-scores. So we go back to the z-score. We took it from that z-score chart. We're going to reject the null if z is less than or equal to negative 1.64. So in this example, because we are determining that the cholesterol levels would be lower, we're going to say less than or equal to negative 1.64, because that is our critical value, aka our decision rule for the z-score test that we're using, right? We chose a z-test. Okay, so now we're going to calculate that, right? And then remember, none of these values are the same as your assignment. I'm just going through them for the purpose of an example. But as you can see in this example, we do end up with a negative value. So you are going to plug in all those variables that were given to you, right? They were all given to you up here into your equation. And then as you can see, we came out with a negative value, and that's okay. And even this value doesn't fit on the chart, and that's okay. And your assignment may have a very negative value too. So because this is negative 12.79, which is much less than negative 1.64, we will, based on our decision, reject the null, right? So we rejected it. And then what does that mean? That means that the cholesterol levels of women who followed a vegan or vegetarian diet were lower than the general population. As you can see, it was negative 12.79 for our z-score test, which is less than this, right? So that means that the values were much less. So their cholesterol levels are going to fall below the population average of 13.6, which means that we are going to go ahead and we're going to reject the null that they are equal, right? That was our null. Our null says cholesterol levels who follow a vegan or vegetarian diet are no different than cholesterol levels of adult women. Population mean is equal to the cholesterol level of those with a vegan or vegetarian diet. We're rejecting the null because clearly it's lower. So we're going to say that yes, the cholesterol levels, are lower for adult women who follow a vegan or vegetarian diet in this particular example. And for your assignment, you will have different numbers, but these are all the similar steps and you will have similar information. Remember, these values, I've had several students ask, these values are given to you in your assignment for you to plug into your equation. This is the reason why I explained earlier that you use the population mean, is because you're comparing your test group, these people following the vegan or vegetarian diet, to the population mean, because that is the hypothesis that we happen to be testing. And here we want to make sure that it's lower. That's why this is a less than sign. And that's also why we're using negative symbols, because we're doing the left side of that tail right here. I really hope that this has helped with the understanding of the assignment, and this will also help you when you are doing your final project, when you are writing your null hypothesis and trying to determine, analyzing whether or not your particular population group is, when you're comparing it to the rest of the population. I apologize, I'm doing this right before I'm going to have dinner on New Year's. I hope you guys have a good night.